Good evening and welcome to September. And tonight I'm going to show you some of the highlights for looking at the nighttime sky. So you want to grab star map for the month of September from skymap.com and look it over, and then this will show you all the wonderful highlights that the map can offer. And then any one of these astronomy apps, pick an app of your choice, and then there are all the different kinds, and some you have a lot of information, some have just the right amount of information. So pick an app that will work for you so that you can learn, use it, and learn about the nighttime sky. And so let's take a look at what's coming up for the month of September. The autumnal equinox will occur on September 22nd at 10:30 a.m. And at that time, the sun is going to be about 45 degrees above the southern horizon. So then we're going to get about 12-hour days and 12-hour nights. You may have already noticed that, gosh, the sky has changed. It changed the color. And you'll see a noticeable change in the temperature as well. So the days are about 12 hours. So after the equinox, the days are going to get shorter than the nights until we reach the solstice on December 20 and 21st. And so this is the kind of the year that we see a transition in season in a way. And equinox, actually, it means that it's a transition between the summer solstice and the winter solstice. And then you can see that if we go from June solstice to December solstice, so halfway there, both the north and south pole are equal distance to the sun. So that's what's called equinox, equal. So nearly 12-hour days and 12-hour nights occur in both equinoxes in March and September. So let's take a look at the highlight for the September nighttime sky. And we're facing towards the north. So anytime you want to learn about the nighttime sky, you want to get your compass bearing. So first face towards the north, and we're now roughly a few hours before midnight. And first thing you want to do is look for the 7 stars of the Big Dipper. And right about now in September, it's going to be just above the northern horizon and considerably lower. And so there are the 7 stars, recognizable, the Big Dipper. This is actually an asterism, and it's seen as a spoon in the sky. It's a very useful guide to help you find other stars in constellation. It's in the constellation of Ursa Major, which is seen as the Great Bear in the sky. And so before midnight, Big Dipper is going to be low above the northern horizon. Right? So once you find the Big Dipper, you take these 2 end stars at a bowl and draw an imaginary line until you come to the first bright star. And that star right there is called Polaris. This is our North Star, the star that sits above the Earth's North Pole. And it's out of magnitude of roughly about 2, located about 432 light years away from us. And so you'll find Polaris here, and it's at an altitude of 45 degrees, which essentially is our latitude. And so 90 is straight up overhead, 0 at the horizon. And so Polaris star is the brightest star in the constellation of Ursa Minor, sometimes referred to as the Little Dipper. Okay? So there's Polaris, and then we have the 2 end stars of the bowl, and this is the Small Bear. Right? So we have Big Bear and Small Bear. Right? And then if you go back to Ursa Minor, you notice that Polaris is the brightest star. There's the 2 end stars. And then remaining stars make up the bowl, and then the handle pointing straight out. So once you find north, you can find Polaris, and then you have your compass bearing for starters. Right? And then go over here, and you're going to find 5 stars, the letter W. And there we're looking at Cassiopeia, right here. And so here's Big Dipper, here's the Little Dipper, and there's Cassiopeia. And this is seen the Queen in the sky. Okay. So once you find Cassiopeia, this is a good way to find the plane of the Milky Way. And so that's why sometimes I call Cassiopeia to be the queen of the Milky Way. And in September, it arches from the north and go almost straight up overhead and lean back towards the south. And then I want to point out here that this region of the sky right here, halfway up, and those stars are closest to Polaris right here. This region is called the circumpolar region. And that essentially means that those stars and constellations closest to Polaris remain above the horizon. So if I switch back and forth, you notice right here, if I move forward, back and forth, okay, you notice those stars and constellations stay above the horizon. And that's called the circumpolar region. Okay? And so that's important when you're looking at the nighttime sky. And if you're at the North Pole, the North Star will be directly overhead, where the entire sky is circumpolar, rotating counterclockwise. If you're at the equator, the North Star is directly at the horizon. Okay? So this is the start. When you look toward the north, you find the circumpolar region and you find north for the evening sky. So here's Big Dipper, here's the Little Dipper, and there's the W, Cassiopeia, and the plane of the Milky Way. So let's shift over here now toward the south. You face toward the south, okay? And now you notice too that if we go into September, the nights are getting longer and the days are getting shorter. So at the beginning of September, the sunset is around 7:48. By the end of September, it'll be about 6:53. How about that? And sunrise at the beginning will be about 6:30 in the morning, and then sunrise by the end of the month will be about 7 o'clock. So what's happening here is that we're getting less than 12-hour days and 12-hour nights, and so the nights are getting longer and the days are getting shorter. Okay? So that means more time to look at the nighttime sky. So we face towards the south, but actually I want to go back and face towards the west a little bit. Okay? And you may notice that there's somebody hanging out over here towards the west, right at sunset. So I'm backing up a little bit because I want to highlight Mercury. There's Mercury right there. Okay? And Mercury is starting to make an appearance above the western horizon. It's going to be pretty low, only about 5 or 6 degrees. So if you look towards the west, you'll see Mercury. And Mercury is the closest planet to the sun. It's going to be about a magnitude almost 1, not quite, -1. So it's going to be bright, but it's going to be lost in that bright twilight of the sunset. And it's going to be roughly about 1.3 astronomical units. Okay, so some of you might notice that you see Mercury over there in the west. You have to have a clear western horizon to be able to spot Mercury. And Mercury will be in our evening sky for much of September. Okay, so that's the first planet you'll notice. And then if you go over and see right at sunset, say, wow, what's that bright object over there? Well, that is Jupiter. So let's go past sunset and get into Jupiter. Okay, right about there. Okay, and we're somewhere in the neighborhood of roughly 9 p.m. And so let's first go to the west. Okay, and in the west, there for a second, we have the bright star of Aquarius. Aquarius is the brightest star of what we see right up here in Bootes. Okay, and Aquarius is about a magnitude of almost 0, and it's about 37 light years away. And this is a huge red giant star. It's in a constellation called Bootes, kind of an ice cream cone pattern. And then this here is known as the Hercules. Okay? So that's one of the first objects to appear after sunset. Okay? And then we'll continue to look over here. I'm going to bring up the constellation. You see Big Dipper there? There's the Big Dipper right there. Okay? And then you're going to use these 3 stars, 1, 2, 3, and use it as draw it as an imaginary line, go right over here to this keystone pattern of stars. And there you're looking at Hercules, the hero, right? And so here's the Big Dipper at the guidepost, and then you find, if you follow those 3 stars, second, third, and fourth, go right over here and find the keystone pattern of stars, right? But most of the summer was nearly overhead, and it's now above the western horizon. And if you zoom in on Hercules, right between these 2 stars right here, it's a Messier object, right? The 110 bright object that you could see in your own backyard. So if you have Sky Map right there, you would have it listed as one of the objects that is highlighted for viewing. If you look at M13, if you get zoomed in on that, nice and close, you're looking at a globular cluster, right? And this is a favorite of many observers using the binoculars or a backyard telescope. And there you're looking at the Hercules cluster that is located about 25,000 light years away, containing nearly 300,000 stars. It's on a magnitude of roughly about 7, so just on the fringe of being visible to the human eye, but it's best viewed with binoculars. So I highly recommend to look at M13 towards the west. Okay? So let's go over here now towards the south. Okay, and we'll get back to Jupiter in just a moment. Okay, so now I'm going to show you. Okay, so notice right about this time, the Scorpion is starting to disappear. Okay, so there's Antares, the brightest star for Scorpion, but it's going to be pretty low, it's going to quickly disappear. But let's go over here to Sagittarius. In Sagittarius, you've seen the teapot. So look towards the south, and if you see the outline that resembles a teapot, half man, half goat, this is Sagittarius, right in this region. Okay? And Sagittarius is always a popular constellation to look at for the summer night sky. Okay? So while we're at Sagittarius, I want to show you a few highlights here. There's some really spectacular object you can see here in this vicinity. And if we zoom in even more, okay, there's the Omega. Omega, it's usually referred to as M13 or the Swan. Okay, so to zoom in on that, okay, you see a beautiful nebulous cloud, and it's about 5,000 to 6,000 light years away. And this is a object that's about a 6th magnitude, so that means it's just on the fringe that you can see it. And then we have a nebulous cloud combined with the cluster. And if you look at it carefully, you would see what looked like a swan. Right? But it would be about the field of view right there. And you can only see a shade of gray. Right? But it's highly recommended that you be able to see the Omega that's sometimes referred to as the Swan Nebula. Okay? And then while you're over there, take a look at M16. M16 right there, right above M17. And we have here Eagle Nebula. And nebulous clouds are made up of hydrogen. And it's a remnant from a star that has, basically has collapsed. And that's what we're seeing in all these stars in the vicinity. You have stars within there that is lighting up and causing them to be reflective in emission nebula. And then this is about another 6th magnitude star, okay? And this is highly recommended for viewing. And this is known as the Eagle. And in photographs, it's seen the view of a eagle that's flying. Okay? So there's the Eagle, there's the Omega. Those are just a quick example of some of the things that you could see in the vicinity. There's about 16 Messier objects in this part of the sky, and that's why it's very popular in the summer for observing. Okay? And so you see M21, M20, There's lots of clusters in this part of the sky. Okay, so let's go right down here. Take a look at this one here. And this one is a Trifid. And the Trifid is actually three things. That's what it means, Trifid. It's just about 6.28 in magnitude. And what you see here are three regions where we see the dark nebula, reflective nebula, and the emission nebula. The redness is from the gas called hydrogen. And so you can see there's a lot of things you can look at just above the spout of Sagittarius, right in this region right here. And it's highly recommended for viewing. And then right up here, we've been seeing all summer long, we have Jupiter and Saturn. They've been putting on quite a show this summer. Jupiter is now at about a magnitude of minus 2.3. Still fairly bright, and it's an easy object to locate. But we're starting to run out of time to viewing of Jupiter. If we zoom in on it, hey, there's Big J, the largest gas planet in the solar system. And Jupiter, in the backyard telescope and binoculars, I say always is a beautiful object to look at. And there you see the 4 Galilean moons of Jupiter. Right? Now remember, Jupiter only takes 10 hours to turn on its axis for a single day. And what we see now are the 4 Galilean moons are visible in the backyard telescope. And there's about roughly 78, 79 moons that's going around Jupiter, but these are the 4 largest moons you can see in the backyard telescope. And what we're talking about here is Callisto. Okay, that's one right here. And if you click on that, it says one in the moon. It had no atmosphere. It's heavily cratered. Okay? And so that's one in the moon. This is generally the moon that is furthest away from Jupiter. And then if we go over here now to Europa. Europa is always perhaps one of the most talked about moons in the solar system because this is an icy moon. And nothing but thick layer of ice with cracks and fissures, and there's possibly water underneath that thick layer of ice. And so that's Europa. And then we back out and go over here and take a look at Io. And Io is generally the closest moon to Jupiter. And you look at it, another moon that doesn't have an atmosphere. And we see these dark regions. These are the volcanic regions or geysers on Io. Right? And then we go to, the question is, where is Ganymede? Okay, well, Ganymede looks like I see the name, but it must be behind Jupiter. And then also, while we're at Jupiter, sometimes you can see the red spot. Okay, so let me lock in on Jupiter. And then I'm going to move the date up and down. Okay, you can see if we go forward in time, there's the red spot. And at time, the red spot is facing towards the Earth. Okay, and then you just have to be at the right place at the right time. Ooh, September 19th, it actually looked like a great time to look at Jupiter. And you see the red spot is facing towards the Earth. And that red spot is a huge storm in the southern hemisphere. Now I can back up. Remember I showed you the Callisto, Europa. We're still kind of in the same vicinity, but now there's Ganymede. There's Ganymede right there. And this is the largest moon in the solar system. Okay? And so you can see it's also heavily cratered. It does not have an atmosphere. But what's important to note is that it only takes Jupiter 10 hours to turn on its axis for a single day. You can see how the moon changed their location relative to Jupiter. That's what makes it fascinating to look at the planet in the backyard telescope. So Jupiter will be in our view in the evening sky for another about 2 months, but it's going to rapidly disappear from our evening sky. And then it's going to become a morning object later in 2020. And then for 2021, Jupiter is going to be on the other side of Saturn. And speaking of Saturn, let's take a look at Saturn. Saturn is the second largest planet in the solar system. It's not about a magnitude of 0.41 and about 9 astronomical units away. And to zoom in on Saturn, this is the beautiful ring planet. And it's tilted about 25 degrees, so you can actually see the north plane of the ring, which is made up of billions of ice chunks going around the equator. And this is everybody's favorite object to look at in the telescope. And this is also one of those planets that has a very short day of only about 10 hours, just like Jupiter. But it has about roughly in the neighborhood of, in what the latest count is about in the neighborhood of 82 moons. Okay? And the largest moon of Saturn is Titan. And Titan has an atmosphere. Okay? And this is the most studied moon for Saturn because it has a very thin atmosphere. And this is actually visible to the backyard telescope. Okay? So here we have Saturn and then Jupiter side by side in the evening sky. And so we have Jupiter. It's about roughly 4.7 astronomical unit, a -2. And then Saturn is about 0.41, 9.5 astronomical units. So these guys are going to be hanging out in our evening sky for the next couple of months. So check them out. And then, let's back up even more. Nearly straight up overhead, okay, you have 3 bright stars. Vega, and we have Deneb, and then Altair. Okay? So if you connect those 3 stars, we're now looking at the summer triangle. Vega is in the constellation of Lyra. Let's take out those, see there, that look like a parallelogram. There's Vega. Vega is about a magnitude of 0. It's 25 light years away. Okay? And in the constellation of Lyra, the Harp. And then this is where, if you zoom in closely, okay, this is where you're going to find, right between these 2 stars right here, looking at the Ring Nebula. And now this one's a tough one to see in the backyard telescope. It's a magnitude of 8.7. It's very small. This is a planetary nebula where a star has gone nova and it creates what we call a bubble. Okay? There's not a great picture of the planetary nebula, but what we see would look like a sphere with the white dwarf that's left behind. Okay? So the Ring Nebula is tiny, and most people will be looking right at it, not realizing you're looking at the Ring Nebula when you're looking at it. So see if this works, and take those out, take that out, and not much of a Ring Nebula there, but you get the idea where you find a Ring Nebula. Okay, and then go over here. Okay, this is Vega. Now we're looking at Deneb. Deneb is about 1.2 magnitude, about 1,400 light years away. Okay, and this is in the constellation of Cygnus the Swan. Okay, seen as also just the Northern Cross. Okay, the summer triangle itself is an asterism. Okay, so here's Deneb, and then if you go 1, 2, 3, 4, this would be the head of the swan. And let's see if I can get it on the star, because this is actually a double star. Okay? And if you get closer and closer, there we go. Now we're looking at Albireo. Albireo is about a magnitude of 3.2. It's 434 light years away, but in the view of the telescope or binoculars, you see a blue and gold star. And so that's a fun object to look at in the backyard binoculars or telescope. Then over here we have Aquila of Altair, and this is seen the eagle in the sky. Okay? So here we see the eagle, and most constellation or star map would show you as kind of a diamond shape pattern in that area. Okay, and so This is the summer triangle, and in the month of September, before midnight, it's going to be nearly straight up overhead. Okay? And so there's a lot of fun objects to look at in that vicinity. Okay, so now let's continue to move over to, there's Capricornus, Aquarius, okay. This is the region of the sky which really doesn't have a lot of bright stars in the vicinity, right? But this is an area right along here that we see the path or the ecliptic plane of the solar system, okay? And this is where you're going to find Capricornus, the goat, and then over here, Aquarius, the water barrier, okay? And so these are kind of tricky to spot. But if you have your astronomy app on your phone, or you can use Star Map, you can be able to find them. Okay? Let's move over here. Okay, now we're facing toward the east. Okay? And there in the east, you have these 4 stars of Pegasus. So let's back up a little bit more. There's Cygnus right here. Okay, Cygnus actually is in along the plane of the Milky Way. We finish out at Sagittarius. So we started out the program talking about Cassiopeia here. Cygnus, the Northern Cross, flying through the Milky Way, and then finish out in Sagittarius. So there is the arc of the Milky Way. And then if you go back over here, there's Pegasus. Okay, it has a diamond shape. Okay, and this is known as the Great Square. The remaining stars out here make out on the flying horse. Right? And so this is a popular constellation for autumn. And then over here we have Andromeda. Andromeda in a lot of star maps would have a V-shaped pattern. Okay, so you have some pairs of stars there. This is the chain woman right here. Okay, but here you have 2 stars, second pair, third pair. Okay, and then while you're at Andromeda, this is a must-see item. Okay, you're going to look at M31, which is the Great Andromeda Galaxy. The best way to find Andromeda, to take out the constellation, is to go up, there find Pegasus, this first pair, second pair, and also Cassiopeia pointing right at it. On the right-hand side, the arrow's kind of pointing right down there, and this is M31, Andromeda Galaxy. It's about a 3.4. And this is a beautiful spiral galaxy. And if you look at it through a binocular telescope, okay, you can actually see this beautiful spiral galaxy. And believe it or not, when you're looking at it, you're looking at something that is the brightest and furthest object that you can see with your human eye. You can see the bright core, you see the spiral galaxy, and from the ground, you would see it as a smudge, but you can still see the bright core. And then you see the companion, M31, M32, on a really good dark night. But keep this in mind, when you're looking at the Andromeda Galaxy, you're looking at the light that left that galaxy nearly 3 million years ago. So essentially what that means is the light that left that galaxy traveled at light speed, traveling 6 trillion miles a year, would reach your eye tonight, 3 million years later. Essentially, you're looking back in time. And so that's a fun story to tell anybody, your friends or family, when you're looking at M31, and tell them you're looking at the galaxy as it was 3 million years ago. So again, use a guidepost at Pegasus right here. There's the V-shaped pattern. There's Cassiopeia. Right down there is M31. And then emerging from the eastern part of the sky is Mars. Mars in September is going to be about a magnitude of -1. It's actually kind of getting a little bit brighter, -2, -1. And so it's actually getting brighter. It's only about 0.43 astronomical units away. Okay? And so if you zoom in on Mars, it appeared in backyard telescope as pretty much a bright red spot. It's half the size of the Earth. It's known as the rocky red planet. It's the most visited planet in the solar system. We actually have three missions are now heading towards Mars. One is Perseverance, the other one from China, and the other one from, I believe, Arab country, heading towards Mars. And they're going to be sending an orbiter and rovers. They should be arriving there in February in 2021. Then we have two tiny moons, Deimos and Phobos, but they're not visible from a backyard telescope. They're just too small, too dark. Okay, so this is what you would see more or less like this. You would see a small, tiny red dot of Mars. Okay? And Mars will be in our evening sky roughly until the end of the year. And so you'll have plenty of time to see Mars, but you'll be hearing a lot about Mars in 2021 when we finally get those visitors to be visiting Mars by then. Okay? So Mars is going to be just in that vicinity where you look at Pegasus Andromeda, and then you look toward the east in the month of September. Then while you're over there in the east, there's that bright star of Capella. And Capella is about a 0 magnitude, only 42 light years away. But what always kind of a farmer's notation or farmer's saying, if you see Capella over in the eastern horizon before midnight, it's a sure sign that winter is coming. Okay, because just below that is Orion and Friend. And in fact, Capella is part of the constellation of Auriga. Okay? And so you see that bright star over there? Since winter is coming. And then there's the Pleiades. Okay, so that's kind of a teaser right there. You see coming up over the eastern horizon. Okay? So that covers the nighttime sky in the evening. What I want to do now is show you what's going on in the morning. Okay? So just before sunrise, okay? And look towards just almost at sunrise there. Okay, there's Mars. Okay, it's in the constellation of Pisces. And Pisces is known as the fish. Okay, right there. Okay, and then if you look over towards the east, you see this really bright object. There's actually two of them. You have Venus. And Venus is the second planet in order from the Sun. It's at a magnitude of -4. Still really bright. Okay? And so it's very noticeable. But it's about 1 astronomical unit away. So there's Venus. And Venus is going to be just above the eastern horizon. And if you look in on Venus, it's a planet has a very thick atmosphere. Carbon dioxide reflects 75% of the sunlight. Okay? And so that's why it's bright, because it's reflecting so much of the sunlight. And when you view Venus, you can actually see this in good binoculars. It's always in a phase. And that's because Venus has the inside track to the planet Earth, and it'll always be in a phase, but you will never see a full phase Venus, okay? And because that's in the inside of the Earth's orbit. Okay, so that's Venus, and then over here you have Sirius. And Sirius is the brightest star of the nighttime sky. Okay, it's out of -1. Okay? And this is in the constellation of Canis Major. Okay, and I mentioned earlier that we see Capella rising from the eastern horizon. Okay, then there's Orion and Friend. Okay, and so there's Capella way up there now. So that's why you see this group of constellation right here. That is winter, but it's not visible in our evening sky yet, but it's coming. Right? And so that's why you want to see, if you see Capella, this is the group that's emerging in the east. Okay? So go out and enjoy the nighttime sky for the month September, and then you'll see all the highlights.